Welcome guys. Today we are going to solve this question, and the question is, see here, this is the spring. This is the spring, and with this spring a mass m2 and m1 is attached. Okay, mass m2 and m1 is attached, and and the height of m2 from the ground is h. Okay, and guys, when and what happened that from this height the whole spring and mass system has left, okay, with initial zero velocity. Okay, initial velocity is zero. Okay, and when the system collide with ground, what happened that this m2, you know velocity of this m2 just after collision, velocity of m2 just after the collision become just after the collision become uh, 0. Just after the collision its velocity become 0. Okay, we have to find what is the minimum value of h, what is the minimum value of h above the ground, so that this system rebound once again, this system rebound once again. Okay guys, so let's try to understand what is happening in this. When when this system start falling from this height, from this position, what happened, m2 will m2 will collide with ground. Okay, m2 will collide with ground. Let's suppose here it is collide with ground. Okay guys, and just after the collision, velocity of m2, velocity of m2 will become 0. Okay, velocity of m2 will become 0, and but velocity of m1 is not going to be 0, velocity of m1 is not going to be 0. Okay, and 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 it is asking that what is the minimum height, so that it's rebound once again. Okay guys, so just after the collision velocity is 0, and it has to rebound. Okay, this means guys, if you draw the free body diagram, here is the mg and here is the n. Okay guys, okay, so it's if it has to rebound guys, so then this must be 0, and to keep it 0 there must be an upward force. Okay, we are just analyzing what may be the possible. Okay, because until if there is no force in upward direction, this m2 is not going to leave the surface. Okay, it is said that it has written in the question, find the minimum so that it's rebound. Okay, rebound, this means that it after this it start moving upward. Okay guys, so there must be a force in upward direction, there must be a force in upward direction. Okay, f, there must be a force, but question is who is applying this force f, who is applying this force f. Okay, and if you analyze the situation, you will find that this force is applied by spring, this force is applied by spring. Okay, so now we are going to draw free body diagram of this. Okay, we are going to draw free body diagram of a spring now. So see here, this is spring, and here this force is applied by spring. Okay, this force on m2 is applied by spring, so m2 will apply force on the spring, so this is the m2, sorry, this is the f. And now the spring is massless, so net force on the spring should be 0, so this will be the f. Okay guys, this will be f. Okay, in this direction. Okay, now so if you, what is the force on, see here, this is the force on f, m1. Okay guys, this is the force f by spring on m1. So it is clear that that see here, direction of the force, see what is the direction of force on m1 by spring. Okay, and by this, if you have no some idea about spring, you will analyze that, guys, first thing is that, spring is exerting force. Spring is exerting force. So, the length of spring is not going to remain L. Length of spring is not going to remain, un okay, unstressed. Okay, length will be increase or decrease. Okay, now if you see here direction of the force on m1, okay, if you see the direction of force on m1, you'll find that, length of spring is going to be increased. Okay, length of spring is because, spring always try to pull the object in, toward this equilibrium position. Okay, so, length of spring is going to be increased. Length of spring is increased. Okay, okay, length of spring is going to be increased. This means, how the motion is happening here. Okay, guys, how the motion is happening here, here this m2 collide with ground. This m2 collide with ground, and then, this spring come downward. It reached to a minimum, maximum compression, and then, it start moving upward. Okay, it start moving upward, and it reached to a maximum extension. Okay, so motion will happening in this manner. Okay, and don't bother if you are not going to understand it. Okay, because it will take some time and a lot of practice. And, if you are in class 11, so it is first time you are looking such type of question. These are the easy one, but, some technically a tough problem for you. Okay, so don't bother if you are not getting my point. Okay, don't bother, it's need a lot of practice. You should do a lot of practice. Okay, guys. So, okay, now, okay, so come to the question. We are, here, till now we had just analyzed how motion is happening. Okay, how motion is happening. Okay, okay, and so come to the question, how to solve the question like this. Okay, I'm just, erasing it. Okay, so, you know so it has asked that, what is the minimum value of h so that this m2 rebound. Okay, so, you know I am going to draw free body diagram of this m2. Okay, guys, this m2. So, i'm not I will not explain a lot of things here, because, you are not able to understand. A lot of explanation is not good for, study. Okay, so try to resolve your problem by yourself. Okay, so this is the m2, which is force on. Okay, guys, and, this is n. Okay, and I am saying that, m2 has to rebound. Okay, so this force must be 0, must be 0, because, if it is going to rebound, so, this m2 will just to leave the surface. Okay, in that case n should be 0. Okay, so, to rebound there must be a force in, this direction. So question is, who is applying this force? Who is applying this force? Is spring. Okay, so spring, this force will be, let's suppose kx. Okay, guys, so let's draw the free body diagram of spring. So here, see here, this is the kx. Spring is massless, so net force on spring is going to be 0. Okay, guys, so, here from this you will analyze that, the length of spring is going to increase. Length of spring will increased. Okay, this means here, extension is taking place. Okay, will increased. Okay, okay, now, So okay, so guys, here, just after the collision, just after the collision, you know potential, just after the collision, energy of the whole system is going to be conserved. Okay, just after the collision, energy of whole system is going to be conserved. Okay, so let's we are just going to analyze condition just after the collision. Okay, and then we are going to analyze first condition just after the collision, then after a long time after the collision, then okay. So just after the collision, what will happen? Let me erase you know these things. Okay, I don't think it is required for you now. Okay, so here this will be the let's suppose m2. Okay, and m1 will be somewhere here. Let's suppose this here will be the m1. Okay, here will be the m1, and they are attached by a string. Okay guys, so just after the collision, velocity of this will be going to be 0. Velocity of this will be going to be 0. Okay, and here there between there is no collision, there is no nothing will happen between kinetic energy, about energy of m1. Okay, so m1 energy of m1 is going to be conserved. Okay, energy of m1 is going to be conserved. Okay guys, so what is the energy of m1 just after the collision? Energy of m1 of m1. Okay guys, let's suppose this height, here this length is l. Okay, so initial velocity of this system is 0, and at this point let's suppose potential energy is 0. Okay, so what is the energy of m1? What is the energy of m1? Because here there is no effect of energy on collision of energy of m1 on collision of m2 with the ground. Okay, energy of m1 is not going to be affected by collision of m2 with the ground. Okay, so energy of m1 is going to be conserved. Okay, energy of m1 is going to be conserved. Energy of m1 and spring. Okay, let me say correct. Energy of m1 and spring is going to be conserved. Okay, plus energy of spring is going to be conserved. Okay, so what is the potential energy of m1? So this will be m1gl. Okay, m1gl. Okay guys, now see here one of the important thing here which I should tell. This is the m2, here this is the force m2g, and here this is the kx. Okay guys, and it is just about to leave this ground. Okay, so it is a very important concept here. N2 is here, this is the n, and it is just about to leave, so n is equal to 0, and this should be the balanced. Okay, so kx is equal to m2g. Okay, kx is equal to should be equal to m2g. Okay guys, and in this situation there should be extension in spring. Okay, there should be the extension in spring. So guys, this is the h, so spring will be some, the m1 m2 m1 will be somewhere here. Let's suppose m1 will be somewhere here. Okay, so what is the potential energy, and okay, and this is the, now guys, this is the maximum displacement. Okay, this is the maximum displacement. You should think why. Okay, this position. Okay, this position, see here, this position, maximum displacement. Okay, maximum displacement, from vertical, from this vertical. Okay guys, maximum displacement from this natural land position. Okay guys, so I should write, so we have to calculate what is the potential energy at this point. Okay, we have to calculate what is the potential energy at this point. Okay, so here I had assumed that potential energy at this point is 0, so this should be equal to, because energy of mg plus spring is going to m1, sorry, energy of m1 plus spring is going to be conserved. Okay, so m1 gl, this should be equal to here m1. Okay, we have to find this height plus this height. Okay, so m1 g, and this side be l minus h plus x. Okay, because this yeah, this length is x, this length is x. So from here to here this is h, so and this height will be l minus h, so mg l minus h plus x plus potential energy plus potential energy of spring, that will be half kx square. Okay guys, so if you look at this you will find m1g h is equal to m1 g x plus half kx square. Okay, okay guys, so what will be the h? H will be basically yeah, x plus half k x square divided by m1 g. Okay, and guys, here if we I can find what will be x by this value. Okay, by this equilibrium, so kx is equal to m1 g. Okay, so what will be the x? X will be, if you think here, m1 g by k. Okay, this will be the x. So let's put the value of x. What we find that h is equal to m1 g by k plus half, see here, this is the k divided by m1 g, and this will be m1 g square by k square. Okay guys, sorry, this will be m2g, m2g. Okay, so if you look at this, I can take m2g by k as a common, m2g by k, I had taken it as a common. I'll find 1 plus 1 by 2. See here will be m1, sorry, here will be m2 by yeah, m1. So we it will find what this quantity become let me write here, this quantity become let me erase something. Okay, this quantity become m2 g by k 2 m1 plus m2 divided by 2 m1. Okay, so and this is the h, this is the h. Okay, okay guys, so this is one of the most simplest questions, super simple question. Okay, and guys, most important thing is, which you have to think, is how motion of this system taking place. Okay, okay, let me give some important point. which will help you. Don't see how I have solved it. It is very simple question, and you can solve it by applying energy conservation. Okay. So what is the important thing which you should consider is, okay, energy of m1 plus spring, energy is going to be conserved. Okay, this energy is going to be conserved because there is no external force working on it. Okay, there is no external force working on it. Okay guys, so this energy is going to be conserved. Okay, first thing, energy of a spring, and and this is going to be conserved. Okay, m1 and spring, not m2. Energy of m2 is not going to be conserved, but energy of m1 and spring is going to be conserved. You should think why. Okay, and if you get your answer, you will learn a very important concept of collision. Okay, if you get your answer, okay, you should think why energy of m1 plus spring is going to be conserved but not m2. Okay, okay, first thing. Now second thing is, you have to think what will happen what will happen when m2 will just to rebound. Okay, just to rebound. Okay, and guys, here the freeboard diagram of m2 is going to help you, okay, to understand this concept. What will going to help you, free body diagram. So here I am drawing free body diagram. m2g, this is here, this is n1 normal reaction. And guys, if I'm saying that it is just to rebound, so there must be an external and upward action force. Okay, and this force will be by spring kx. Okay, so if you analyze, okay, this, okay guys, so if you analyze this, you find, you able to find, okay, whether there is compression or extension in spring. Okay, you able to find whether whether there is extension or compression or tension in spring. Okay, find or analyze whether compression, let me here write down here, compression or extension, or I can say tension in spring. Okay, guys, and if you able to analyze these two or these two things, then you are able to understand whatever solution I have given to you. Okay, and these 2 points are very important. Okay, so and here I am not going to deal, okay, these two concepts to you here right now, because if I deal, it is a big concept. Okay, it will take slightly time if you are in class 11th student. Okay, so it will take nearly 1 or 2 days to understand this concept. Okay, to understand these two concepts. Okay, don't bother, because it is a big problem. Okay, it is a good but one of the most simple question. Okay guys, so you should think about these two things. Okay, and then you try to solve the question by yourself. Okay, and if you are not able to solve, then you should see my solution. Okay, thank you. Hope you guys you like this. Thanks for watching. Okay, thank you for watching.